Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, and here we are going to evaluate this integral involving the famous Dirac delta function. So here we have the integral 0 to pi dx sine 3x cos raised to 4 6x and delta of x minus pi by 2, right? So we'll see how we can solve this integral by using the definition and property of Dirac delta function. So first of all, let us rearrange the terms. So we can write 0 to pi, and here we have sine 3x cos raised to 4, and here we have 6x and delta of x minus pi by 2, and here we have dx. Now see, we define the delta function as the delta of x is equal to 0 for x not equal to 0 and infinity for x is equal to 0. So we know that the delta function is infinite at x is equal to 0, and for all other points except x is equal to 0, the delta function is 0, right? So here if we define delta of x minus a, delta of x minus a is equal to 0 for x not equal to a, and delta of x minus a is infinite for x is equal to a. So here we have x is equal to a, and the peak, the spike is this delta of x minus a is infinity for x is equal to a, and for all other points except x is equal to a, the delta function is 0, right? So if we take this function as f of x, then we have 0 to pi, and here we have f of x and delta of x minus pi by 2 dx, right? Now see, from the definition of delta function, we know that if we have a function f of x associated with the delta function, then the value of this integral is equal to the value of this function f of x at this point, that is x is equal to a. So here we have f of a. So if we compare this integral with this one, then we can see that the bounds are 0 and pi, and the value of a is equal to pi by 2, and f of x is sine 3x cos 6x raised to 4. So the value of this function, using this property, we have f of a, and a is pi by 2. So we have f of pi by 2, and our function f of x is sine 3x cos 6x raised to 4. So we'll take x is equal to pi by 2 in f of x. So we can now write sine 3 pi by 2, and then we have cos raised to 4, and here we have 6 times pi by 2, right? So this is sine 3 pi by 2 has value minus 1, because sine 270 degrees is equal to minus 1, which is 3 pi by 2. So this is sine 3 pi by 2, and here we have 2 times 3, that is cos 3 pi raised to 4. Now see, from trigonometry we know that cos of k pi is equal to minus 1 raised to k. So here k is 3. So we have the value of cos 3 pi as minus 1 raised to 3. So minus 1 raised to 3 is minus 1. So we have minus 1, and cos 3 pi is minus 1. So we have minus 1 raised to 4. So we have now minus 1, and this is an even number, so minus 1 raised to an even number gives us plus 1. So this is minus 1. So the value of this integral is equal to minus 1. Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function. So here in this class we will discuss this integral that is 0 to pi, and here we have theta and the absolute value of sine theta and delta double prime theta minus pi by 4 d theta. So here we have to evaluate this integral involving the famous Dirac delta function, right? So let us call this integral as I, and here we can see that the absolute value of sine theta is involved, and the second derivative of delta function it occurs, right? So let us see how we can solve this integral by using some properties of Dirac delta function. So here we'll make use of this property of delta function that is integral minus infinity to infinity, and if we have a function say f of theta, and here we have the nth derivative of delta function and theta minus a d theta, then the value of this integral is given by minus 1 raised to n, and the nth derivative of this function f of theta evaluated at this point, that is a, right? So here we have this integral, right? So let us compare this integral with this one. So f of theta is given by this function. So f of theta is theta multiplied with absolute value of sine theta, and here we have double prime, so it implies that the second order derivative of Dirac delta function is involved. So n is equal to 2, and here the value of a is pi by 4, and obviously this point, that is a pi by 4, it belongs to the interval that is 0 to pi. So here we have the mod of sine theta, and theta varies from 0 to pi, and it implies that we are in the first and second quadrant, right? So here we have the first quadrant, this is second quadrant, and theta varies from 0 to pi, and we know that when we take any value of theta lying in the first and second quadrant, then sine theta is positive, right? So when theta belongs to the interval 0 to pi, then sine theta is positive. So we can write mod of sine theta is equal to positive sine theta when theta belongs to the interval 0 to pi, right? So f of theta now takes the form theta sine theta. So now we can write this integral I as 0 to pi. We have theta sine theta and delta double prime theta minus pi by 4 and d theta. So using this result, we have the value of this integral as minus 1 raised to n. N is 2. Here we write 2, and then we have f of second derivative. So second derivative of f of theta at this point, theta is equal to pi by 4. So here we write pi by 4. So minus 1 square is plus 1. So we have f second derivative of f at pi by 4. So now let us differentiate f of theta. So f prime of theta is d by d theta of theta sine theta, and here we can use the product rule for differentiation. So we have theta, the derivative of sine theta is cos theta, then we have sine theta, and derivative of theta is 1, right? So we have theta cos theta plus sine of theta. Now see, here we require the second derivative. So second derivative is obtained by differentiating this function, that is theta cos theta plus sine theta. So now we can write d by d theta of theta cos theta and the derivative of sine theta, right? So here again we'll apply the product rule. So first function, then derivative of cosine theta is minus sine theta, and then we have cos theta, and derivative of theta is 1, and the derivative of sine theta is cos of theta. So now we have here minus theta sine theta, and then cos theta plus cos theta is 2 times cosine of theta. So the second derivative of f of theta is given by this expression minus theta sine theta plus 2 cos theta. So now we have to evaluate this derivative at this point. Theta is equal to pi by 4. So now taking theta is equal to pi by 4, we have minus pi by 4 sine pi by 4. Then we have 2 cos pi by 4. Now sine pi by 4 is 1 over square root of 2. So here we have 1 over square root of 2, and then we have 2 times 1 over square root of 2. Now taking 1 over square root of 2 common, we have minus pi by 4 plus 2, right? So this expression can also be written as minus pi plus 8, 4 times 2 is 8, divided by 4 times square root of 2, right? So the value of this integral is equal to minus pi plus 8 divided by 4 times square root of 2.